Hi everyone. Today I'm going to explain for computer networks where I have came across with the research papers. I have done research paper which is TCP-IP model in data communications and networkings, where we are going to compare OCI model, OSI model, and TCP-IP model. So we're gonna cover up all the research paper contents in this PPT. So in this video, which is about 10 minutes of this video, we're gonna cover all the things in details. So we're gonna make you efficient that we're gonna save your time. Let us cover. So before going that, I will introduce myself Dhanvantesh. So I am from Aryabhatta CSC from SVC Bangalore. Let us dig agenda. So before going with this entire PPT, we're gonna cover the table of content, which is agenda. So we're gonna cover up first abstract, and then introduction, and then architectural principles, and then comparison between TCP, IP, and OSI models, and at last conclusions. These all are the topics which we're gonna cover in the research paper. So this all will be covered in this video of 10 minutes, where you no need to worry about 4 to 5 hours which gonna take up completing one research paper. So in this we gonna cover all the details which is summarized and more efficient for you guys. What do you mean by abstract? Instead of reading a lot of details like research paper, in a research paper we're going to go through some all details, right? So instead of going with all details, there will be abstract in a paragraph that. So instead of going with all the details, if you go with that, so you will get some knowledge like why we are going to study, and what are the benefits we're going to achieve, so or get. So that's the abstract one. Let us discuss that first. What is the abstract here? The TCP/IP Transmission Control Protocol Internet Protocol is a set of communications protocols used for networking and particularly on the internet. So you can see this mobile which is connected to the internet, right? So I can get a message from someone else, right? So using a WhatsApp, Facebook, Instagram, I can do many things. Likewise, there will be packets. So when I send a message to my friend, it goes to from the packets, but we cannot see that those packets. Actually, there is a small gap. It's going from packets only, so we will assume as a packets. That's it. So packets are packet. Packet cannot be packet. That's it. And it allows for end-to-end data transmission by defining how data is packetized and addressed and transmitted and routed and received. Right? If I send a message to the my friend, so he will receive a packet size, right? So it is addressed first. It is packetized. Then it addressed that where my friend is located, and it is transmitted and through the routed like networks, and it will get the received packetized. Then encoding and decoding will be happen. This is called inscriptions or description, which is going to be covered up later. So the should consist of 4 layers whenever send messages, right? So it consists of link layer, internet layer, and transport layer, applications layer. So the link layer manages communications within a single networks and connects all across different networks. And transport layer ensures a reliable host-to-host communications. And application layer facilitates data exchange for application. Next is the introductions. So in these introductions, we're gonna cover up all like 4 points. TCP/IP Transmission Control Protocol and Internet Protocol is a key communication frameworks used on the internet, comprising two main layers. One is structure. The structure is like TCP breaks messages into packets and resembles them at the destination, um, while IP handles uh, addressing to ensure packets uh, reach uh, reach the current locations. Routing. Routing, like each gateway checks packet addresses for efficient routing, allowing packets to take different paths. reassembles collecting upon arrivals. Client server model functions on the model where user requests services from another computer. Stateless communications. Each request is treated independently, optimizing network resource use. So next we will go with the architecture principle of TCP/IP. So what do you mean by TCP is transportation protocol, right? So this is a network model and encapsulations. The applications, you can see, you can check it out that there is an application transport internet network interface, right? In application there will be user data, and in transport we will have TCP header and user data, and in internet we're gonna have IP header and TCP header and user data. And in network interface we're gonna have one extra more packet, that is a internet header. So the architecture principle of TCP and IP, which is nothing about transmission central protocol, and IP is nothing but internet protocol. So this is an end-to-end principle, means intelligence is maintained at the network's edge, meaning the internet itself does not store state information. Robustness in principle. Be conservative in what you send. Be liberal in what you accept. This means sending well-formed packets while accepting any valid data packets. Encapsulation. Each layer of TCP/IP uses encapsulation to provide abstraction, meaning that each layer adds its own address to the data as it moves down through the layers. Then the TCP/IP model layers. So what are the layers functions? Before that, we have been discussing the four layers, which is like application layer, transport layer, internet layer, and link layer. So in OSI, we have three more layers. We're gonna discuss at that comparisons when we're comparing the port. So we're gonna discuss on that later. So this application layer interfaces with user application and user protocols like HTTPS, which is a hypertext transmission protocol. FTP is like file transfer protocol, and SMTP is a smart buddy. Okay, don't worry about those things. This is transport protocols or provides communication service to applications like TCP for reliable transmission and UDP for faster and less reliable transmission. Yeah, what do you mean by TCP and UDP is nothing but think. Uh, TCP is a collection, UDP is a collection less. That's it. Internet layer manages routing and addressing with protocols like IP. So link layer facilitates local network communications and transmission of data frames. More over to the next slide. So comparison between before conclusion, we're gonna discuss about this comparison between TCP, IP, and OSI models. Layer structure. We will have TCP, IP, OSI. So TCP have said that it has four layers, which is application, transport, internet, and link. So OSI has seven layers, which has three more layers than four layers of TCP, which has like presentation session and then data link. I'm in physical layer. So application layer. So in TCP, we combines the function of OSI application presentation session layers into one layer, but OSS separates this function into distinct layers. Protocol development. So focuses on particular practical application and is not intended to the OSI complaint. OSI developed as a standardized model for network protocols. Management protocols, TCP and or IP, incorporates a function like error handling and routing without a strict management framework. So OSI has defined protocols for network management like ICMP and IGMP. Well, overall, we came up to the conclusions. In conclusion, we're going to discuss these 4 points: no specific requirements, and wide implementation, and developer focus, and assess via sockets. You can see out the layer 1 is physical, layer 2 is data link, and layer 3 is network, and layer 4 is transport, and layer 5 is session, and layer 6 is presentation, and layer 7 is application. Oh my god, and these are the layers, okay. Developer focus. Programmers primarily interact with the application and transport layers, while lower layers are managed by the operating systems. So this all topics or the contents has been discussed enough, right? So we made simple and not complex, not too much complex. So thank you for watching.